everyone, welcome back to KWS Patterns. In this tutorial, I'm going to demonstrate to you how to construct an orthocenter. And an orthocenter is literally the intersection of three altitudes of a triangle. Now, I did a previous video on how to construct an altitude, and I want to show you from here what it looks like. You have to do an altitude from vertex A, so you have to cut this segment which is below that vertex and create it's literally what you're doing is creating a line that is perpendicular to segment CB but passing through that, but from a point that is not on the line, and this point would be the vertex in this case. So that's the method. And I also did a video on how to do a perpendicular bisector for line segment that is from a point not on the given line. So, and then this would be your altitude. So I'm going to demonstrate to you how to do that on an obtuse triangle. Okay, I'm going to demonstrate that for you. So I'm going to start out here with my obtuse triangle, and first thing that we have to do, we have to extend this line segment ZY. I have to extend it because although I will need whatever arc that I'm going to create from vertex Z, right, which is coming through here, slide my pointer down to here, do another arc, okay, slide it over to the intersection of the line and there, of the line and the arc, the extended line or the auxiliary line. And now I'm going to draw a line from the vertex X, and this line is going to go through my intersecting arcs right here. Okay, and this is your altitude, and because of the altitude here, we're going to have perpendicular lines that are forming here perpendicular to this extended line also. Now I have to do this, repeat the same steps to be able to create an altitude, right, from vertex Z, but it's going to be going along that segment XY. So I'm going to create an altitude from here, vertex Z, place my pointer there, and I'm going to come in a little bit because I just needed to intersect in two places, right? Slide it over to the other intersection, and that is now. So what I need to do from this intersection right here, going through my vertex, right, I'm going to do this, create the line through, all right, and that's your other altitude. I'm going to create now another altitude from vertex Y, and in order for me to do that, and I can test this for you, but I can tell you off the top that I'm going to have to do another auxiliary line and extension, because this is going to cut it. I needed to cut the line in two places, and I just have to create another auxiliary line. So in creating the other auxiliary line, right, I'm going to use the segment XZ and I'm going to extend it. So when I do the extension and XZ, right, you can do a solid line if you want, but I use a dashed line to show that it is an extension. So I need my little bit more than half passway. I don't need it a lot here. And notice, because it did not show me exactly where the intersection is, I'm going to just make that a little bit clearer so I can be precise, okay? And I am going to go from the intersection of both of those, and I'm going to swing an arc here in the open, go from the intersection of this one, swing an arc here also. Now what I'm going to do, I'm going to draw a line right, from vertex Y through the intersection of both arcs, right? So from vertex Y through the intersection of both arcs, I'm going to draw my line there. Okay, line it up properly. All right. And you'll notice that the three altitudes meet here at this point, and where they meet, this is our point of concurrency. And to be precise, because we're dealing with altitudes here, this is called the orthocenter. All right, orthocenter. And this is where three altitudes of a triangle meet. All right, three altitudes of a triangle. Okay, that's your, what we call our orthocenter. Now this, as I said, is being done on an obtuse triangle, and you notice it's meeting outside of the triangle. And let's look at another type of triangle, which this is the acute triangle. And an acute triangle, right, it's going to meet right here, because I did it from all the vertices. I created it beforehand. Didn't want this video to be long and drawn out. So it's meeting inside, and this is what we call our orthocenter. Point of concurrency, this is our orthocenter, okay? And this meets on the inside, all right? It meets on the inside of the triangle. Meets inside, and this is an acute triangle. Now I will demonstrate to you on the right triangle, but the right triangle is unique, and I'll say this because, for instance, this, if we just extend segment MN, that would be your altitude. So this is why I'm showing you this, because this is your altitude right here. Just do an extension. If you extend also segment MN, this will also be your altitude, okay? And all you have to do now is just simply create, right, an altitude from the vertex here, the right angle, MN, the vertex N. You are just extending this a little bit past. You just need a little bit, not a lot. All right, a little bit past the line, segment MO. And where the two arcs intersect, create one over here. Where these two arcs intersect, create one there. All right, and then all you have to do next is simply draw a line from the vertex, which is N, through the intersecting arcs, right? And you get this to be here. Now you'll notice that where the three lines meet is simply on the edge, or on the vertex, or at the right angle where the triangle form, and this is your orthocenter. So we can create a table there, right? Again, once again, and say for an acute triangle, and we have our symbol there for triangle. You can say that it meets on the inside, and that's the orthocenter. It meets on the inside. And for the right triangle, it meets on the corner of the right angle. Okay, right there meets. And then we know that for the obtuse one, it meets outside. Okay, obtuse one, it meets outside. So you need to know where these meet. It is very necessary to know them, because you never know what type of exam you're taking and what memory you need to retrieve from your memory box in terms of these types. So for a right triangle, it meets right on the edge or on the tip of the right angle right here. And for an acute triangle, it meets inside the triangle. And I told you also, and I told you I would demonstrate to you for the obtuse triangle, it meets outside. So that's it for the orthocenter of the 3 different types of triangles. Thank you for watching my video. Please like, subscribe, and share with others. See you soon. Bye.